I'm Catherine in Group B16. My group mates are Max and Rajiv, and this podcast is brought to you by the website on your screen. So for this project, we're doing permutations with indistinguishable objects and the multinomial theorem. I'm going to start off with permutations with indistinguishable objects, and here I'm going to start with a simple permutation. So we have 4 elements here, which is each letter, and you can arrange these different elements into different combinations. So you can write it as live. That's one combination. Another combination is evil. So as you can see, I've made 2 words here, so the order of these elements in which they're placed is important to the combination. So now I'm going to go to indistinguishable objects. So that is when an object have indistinguishable elements in a counting problem. So here we have winning, and winning has 3 N's and 2 I's, and you can move these N's into any other place and it will still be the same word. You can also do the same thing with I's. You can change them and it will still be the same word. So the N's and the I's are indistinguishable. Okay, so this is the formula for indistinguishable objects, and because you can arrange winning into different combinations and still have the same word, we have to account for that in the equation. So the first part is the number of spaces. So we have 7 spaces, so 7 factorial, over these n1, n2 to nk means the number in the indistinguishable group. So we have 3 n's, so 3 factorial, so it's 7 choose 3 times 4 choose 2, because that's how many we have left, and then there are 2 i's times 2 choose 1, so we have 2 elements left, and we have 1 w, and then 1 choose 1, which is 1 factorial over that. So this is the number of n's, this is the number of i's, w, and g. So you can cancel these out, and this equals 7 factorial over 3 factorial times 2 factorial times 1 factorial times 1 factorial. So that is the equation for winning in the possible combinations. Alright, so Max is now going to do the multinomial theorem.
Okay, multinomial theorem helps us prove an easy way to get the coefficients and powers of different terms when you take a polynomial to the n power where n is an integer. And the polynomial has m elements. Okay, so an easy way to get an understanding of this is using the binomial theorem, which we all know to be x plus n to the n equals summation of n choose r, x to the n minus r, y to the r. Now, to help us understand multinomial theorem, we're going to add an extra element and go that to the n, and then from there just use m elements where we don't know how many elements m is. So from this we can group the x and the y together and make them act as one element. And this way we can kind of reuse the binomial theorem, and this would become to n of c r of x plus y to the n minus r 1 times z to the r1. So this is reusing binomial theorem, and now we have another element in here, x plus y to the n minus r, that we need to also expand. And so for that one, what we do is bring this out, and this will become x plus y to the n minus r1 equals summation, just using binomial theorem again, r equals 0 to the n minus r1, and c of n minus r1, and then this time just a different number r2 to show the index of which number we're going to, which element, and then we have x to the original number, which was n minus r1, and then minus the second index, which is r2, and then y to the r2. Now this, all of this becomes the summation of r equals 0 to n of c and r times the summation r equals 0 to n minus r1 times c of n minus r 1 r2 times x n minus r1 minus r2 y to the r2, and then z just to the r1. Alright, and so then that will combine together to show the previous theorem where the combinations will combine together to a function that looks like this, and then here we've got our x, our different integers to the different n powers. Now, to illustrate multinomial theorem, I'm going to do an example just with 3 terms. It's pretty simple, and then we'll take this and we'll just square it. Okay, and so then using multinomial theorem, the first term is going to be 2 factorial over 0 factorial, 0 factorial, x to 0, y to 0. And then every index we just go over 1, and then that's how we get each of the powers to their respective place with their respective integer. Okay. And one more element. It's just, oops. Turns into just, as you can simplify it in your head, 2xy z plus 2xy And that was an example shown by the multinomial theorem. It was Group B16. Hope you enjoy.